Hey guys, welcome back to my channel. Today we're going to do a video on histograms. This video consists of exam questions 2018 onwards for IGCSE Edexcel Maths A. If you're someone who's looking for other topic revision questions using exam papers, you can check out the link above because in this playlist, I have made a video for each topic that comes in the IGCSE Edexcel Maths A. This playlist can also help you if you're preparing for your GCSE Edexcel Maths, Cambridge Maths, or even O-Level Maths. So let's see how hard these questions are and what kind of tips and tricks you need to keep in mind to solve histogram questions. So it says the histogram shows information about the times and minutes that some people were in a shop. So they've given us the entire histogram. They have identified the scale for the frequency density and the class intervals for time. Work out an estimate for the proportion of these people who were in the shop for more than 40 minutes. So in our histogram, more than 40 minutes, this is 40 minutes. So more than that is going to be all of this, and this. So we need to find an estimate for these people. So first thing, for the number of people, we need the frequency. And the frequency can be found using the formula, which is frequency density equals to frequency over class width. So frequency is frequency density times class width. This is the formula that we'll be using to figure out the number of people who are in the shop for more than 40 minutes. So for the frequency density for 50 to 60, we connect this to the scale, so that's 1.7. And for the other one, that is, I think, 1.5. 1, 2, 1, 2, 3, 4. Yep, that's 0.5. Now we have the complete bar for 50 to 60, but for the 30 to 50 bar, we have half of it. So in total, there are 20 squares, small squares inside this. So if we're taking half of it, that means we're focusing on the interval for 10, 40 to 10. So for a calculation for the frequency, 0.5 times 10 for 40 to 50 plus 1.7, which is the frequency density for this bar, times again 10, because the interval is 50 to 60. So 0.5 times 10 is 5. 1.7 times 10 is 17. So 5 plus 17, that's 22. So 22 people were in the shop for more than 40 minutes. Simple as that. This is like the most straightforward question you can get. And as you can see, just for 3 marks. So nothing complicated happening over here. You need to know that frequency density equals to frequency over class width. Class width is like the difference between the intervals of each bar. So for this, it's 10. For this, 5. Then it's 15. This one is 20, and then 10. So you just find the difference of the intervals of the bar. That is your class width. Then frequency density is always your y-axis value. So if frequency density is frequency over class width, frequency is frequency density times class width. So you just find the frequency density value using the graph. Then the class width value is also using the graph. Put them in the equation. Since our focus was on the people who spend more than 40 minutes, so that's why we took half of this bar, not the entire. So for 40 to 50, the interval was 10. So 10 times 0.5 plus 10 times 1.7. And that gives you 22 as the estimate of people who were in the shop for more than 40 minutes. Then the next type of question you can get is that the table gives information about the weights in kgs of the parcels that Pedro delivers on Monday. So we have a table for that. On the grid, we have to draw the histogram now. In the previous question, they gave us the histogram. In this one, we have to draw it. So as you know, the y-axis is the frequency density values. And in the table, they only give us the class intervals and the frequency value. So what you will do is you will make another column over here, which is going to be your frequency density. And for each frequency density, we divide the frequency by class width. So for the first one, 12 divided by 2, 6, 7 divided by 1, 7, 15 divided by 3, 5. 12 divided by 3, 4. 9 divided by 5. That's going to be 1.8. So these are your frequency densities for each interval. So now for 0 to 2, we draw a bar that's at the height of 6. Then from 2 to 3, we draw a bar that's at the height of 7. Then from 3 to 6, we draw a bar that's a height of 5. Then for 6 to 9, it's at the height of 4. And then lastly, 9 to 14, it's at the height of 1.8. So that is your histogram. Then one of the parcels that Pedro delivered on Monday is chosen at random. Using the information in the table, find an estimate for the probability that this parcel weighs more than 7 kgs. So more than 7 kgs means it's going to be over here. So using a histogram, 7 is going to come 1, 2, 3. This is 7. So we have to talk about the probability that the weight is more than 7 kgs. So this and all of this. So for the number of parcels, we know that from 9 to 14, it's 9. For 6 to 9, the number of parcels is 12. But we have to find for 7 to 9. So what we can do is, we know that the interval is 2 and the frequency density is 4. So for 7 to 9, the number of parcels is going to be 4 times 2, and that's 8. 7 to 9, it's 4, the frequency density, times the class width, which is 2. 8 parcels. So for the estimated probability, it's going to be 8 plus 9 divided by the total parcels, which is 12 plus 7 plus 15 plus 12 plus 9. That is the total number of parcels. This simplifies to 17 over 55. That is the probability of the parcel being more than 7 kgs. Then this one, it says the incomplete table and incomplete histogram give information about the times and minutes that 140 people waited at a station for a train. We have to complete the table and the histogram. So we know that the frequency for the first interval is 0 to 5. So let's find the frequency density. So that's 23 divided by 5, which equals 4.6. So we draw a bar with a height of 4.6 for this one. Then for the other one, they gave us the interval and they've given us the frequency density. So if we say that this is 1, this is 2, this is 3, this is 4, this is 5, let's say, okay? Then 10 times 2.5 is going to be 25. And then for this one, 15 times 4 is going to be 60. So now we can check whether the total frequency is the same as 140 because that's the number of people that are in this question. So if we add them, 23 plus 25 plus 60 plus 18 plus 14, that does equal to 140, which means our frequency values are correct. So that means the chosen scale is also correct because this is 1, 2, 3, 4, 5. So based on that, 4.6 is going to be over here. Then other one was 18 divided by 10, that's 1.8. That is this one. And then 14 divided by 20, that's 0.7. So that's going to be this. So this is your complete histogram. For each one of these, I found the frequency density. For this one, it was 18 divided by 10, which is 1.8. And for this one, it was 14 divided by 20, which is 0.7. And for the frequency, I just multiplied the frequency density with the class width, and that gave us 25 and 60. So that's how you can use the given information to complete the histogram. Then says the histogram gives information about the heights, 8 centimeter of some tomato plants. There are 12 tomato plants for which the height is greater than 75 but less than equal to 85. One of the tomato plants is selected at random from this interval. Find an estimate for the probability that this tomato plant has a height greater than 82.5 centimeters now. So 82.5 is going to come. 82.5 is over here. Somewhere over here, that's 82.5. It's between 82 and 83. So to find the probability that this tomato plant has a height greater than 82.5, we are looking at this part over here because it's between 82.5 and 85. So total interval is from 75 to 85. And our focus is between 82.5 and 85. So that means the class width for that is 2.5. Okay, that's the class width. For the frequency density, now we have to figure that out. We have 12 plants between the whole thing. Between 75 to 85, there are 12 plants. So frequency density for that part is going to be 12 divided by the class width. So that's 10. So that's 1.2. This over here is 1.2. So for that specific part, from 82.5 to 85, it's going to be 2.5 times 1.2, which equals 3. So 3 plants are between 82.5 and 85. So your probability is going to be 3 out of 12, which is 1/4. That is the probability that plant has a height greater than 82.5 centimeters. Then this one says the histogram gives information about the heights 8 centimeters of some tomato plants. There are 12 plants for which the height is from 75 to 85. One of the tomato plants is selected at random. Find an estimate that this tomato plant has a height greater than 82.5. So if we draw a line from 82.5 somewhere over here, that's your 82.5. So we need the probability for the number of plants that have a height greater than 82.5. So that includes this part and this part. So we know that there are 12 plants from 75 to 85. So let's use that information to figure out the frequency density for this bar. So 12 divided by the class width, which is 10, that's 1.2, which means the height of this bar over here, this is 1.2. If this is 1.2, then we can figure out the height of this bar, the 85 to 91. So 1.2 is this, which means this is 1.1 and this is 1. So which means this is 0.5. So that means over here, this is going to be 0.4. Yeah. So based on that, the frequency for this part is going from 82.5 to 85. It's 1.2. times 2.5 because that's the class width, plus, and then for over here it's 85 to 90. So 0.4 times 5 because 5 is the class width. So that's 3 plus 2. So that's 5. 5 is the total number of plants that have a height greater than 82.5. So the probability, it would be 5 out of the total number of plants. So for the total number of plants, what we will do is we need to figure out the frequency density for each bar. So then this one would be 0.6. This would be 0.8. This is 1, 1.2, and this is 0.4. So that means for the frequency, let me do that separately over here. We have 0.6 times 5 plus 10 times 0.8 plus 1 times 5 plus 1.2 times 10 plus 5 times 0.4. That gives us 3 plus 8 plus 5 plus 12 plus 2. 10, 22 plus 8, 30. So total frequency is 30. So the probability is 5 out of 30, which simplifies to 1 over 6. That's your answer. So if you would realize by now, they're not very difficult. If you understand the main thing, which is the frequency density part, you can easily solve it because the method is still the same for all of them. Then says the histogram shows information about the total time m minutes taken by each child in a school to walk to school every day for 1 week. Now they haven't given us the scale for frequency density. It says there are no children for whom m is greater than 100. That means no children over here. That's why there's no bar. There are 10 children for whom m is less than equal to 20, which means the frequency over here is 10. Work out an estimate for the number of children for whom m is greater than 50 but less than equal to 80. From here to here. This is our focus area. Okay. So first, let's use this information to figure out the frequency density. So frequency density is going to be 10 out of 20. That's 0.5. So if this is 0.5, this is 1, this is 2, this is 3, 4, and 5. So now the frequency density for this one is going to be 2.9. This is 3.2, and this is 2. So for the frequency, the number of children between this interval, from 50 to 60, the class width is 10. So 2.9 times 10 plus, then from 60 to 75, that's 15 times 3.2. And then over here, from 75 to 80, so that's 5 times 2. 29 plus 48 plus 10. That equals to 87. So that is the estimate for the number of people for whom m is greater than 50 but less than equal to 80. Then this one says some people attend a concert. The histogram shows information about the ages of these people. Work out an estimate for the percentage of these people who are aged more than 55 years. Give your answer correct to one decimal place. So aged more than 55 years. So let's first find 55. 1, 2, 3. That's 55. So let's highlight our region. This is what we're focusing on. They haven't given us any other information. They just said that some people attend a concert. So to work out an estimate for the percentage of these people, we need the frequency. So what we can do is, if we assume that this is x, this is 2x, because we don't know the exact sales, I'm just assuming this is 3x, 4x, and 5x. Two big squares make one unit. That's what I'm saying. Like it makes an x. So for this, your class width from 55 to 75, class width is 20. So this one is 1, 2, 3, 4, 5, 6. 1.6x. That's 5x. That's 3, 1, 2, 3. 3.3x. That's 1.9x. And this is 0.9x. So these are your frequency densities for each bar. So let's first begin with finding the total frequency. So we're going to find the frequency for each bar and add it up. So total frequency 1.6x times 5, because this is 25, plus 5x times 5 plus 3.3x times 10 plus 1.9x times 10, and then plus 50 to 75, that's 25 times 0.9x. That's going to give us 8x plus 25x plus 33x plus 19x plus 22.5x. That adds up to 107.5x. That is the total frequency. So for this interval from 55 to 75, it's going to be 0.9x times 20. So percentage would be 0.9x times 20. That's the frequency of the people who are more than 55 years, divided by 107.5x, and then times it by 100 because you find the percentage. So 0.9 times 20 is 18. 18x over 107.5x times 100. The x get cancelled out. So 18 times 100 divided by 107.5. That's coming out as 16.7%, correct to 1 decimal place. So that is how you solve this one. So remember, you can also assume values for the frequency density. You can say that two big boxes make an x. So x, 2x, 3x, 4x, and 5x. We just created our own scale. And then as you can see, as we solved it, the x did get cancelled out. So you don't need to worry about that. How can you give your answer in terms of x? So basically, overall, we're using the same concept again and again. But the question is slightly worded differently. Like till now, I've used like each different type of question you can come across. Like I'm not doing all of them because obviously like majority of them are the same. So I'm just picking the ones that stand out the most and use a different kind of language or like asking for a different thing, even though the method is still the same, but it's just the way it's worded, it's different. Then this one says the histogram shows information about the ages of all the passengers traveling on a plane. No one on the plane is older than 80 years. 24 passengers on the plane are aged between 40 years and 60 years. So between 40, so these are 24. Work out the total number of passengers on the plane. So using this value, we'll first figure out the frequency density. So that's going to be 24 over 20, which gives us 1.2. So if this is 1.2, let me mark this. That means 1, 2, 3, 4, 5. This was 1. Each small box is 0.2 units. So that's 2, 4, 6. 1, 2, 3, 4. That's 3, 2, 3, 4, 5. That's 5. And that's going to be 7. Okay. So now we can figure out the frequency density for the other ones. This is going to be 0.4. This is going to be 1.2, 1.4, 1.6, 1.8. This is 6.4. This is 2. This was 1.2. And this is going to be 0.8. 2, 4, 6, 8. Yeah. So that means total passengers are going to be 0.4 times 10 for the first interval plus 1.8. I don't know why I wrote 1.18. That's 8. 1.8 times again 10. Then 6.4 times 5. 2 times 15 plus 24, which is already given, and then 0.8 times 20. This equals 4 plus 18 plus 32 plus 30 plus 24 plus 16. That all adds up to 124. That is your total number of passengers. Then a passenger on the plane is picked at random. Work out an estimate for the probability that this person is older than 55 years. So older than 55 years is now going to come 1, 2, 3, 4, 5. So for the frequency, we'll do 5 times 1.2, which will equal to 6. So probability is going to be 6 plus the number of people over here, which is 16, divided by the total people, which is 124. But it says more than 55. So more than 55 focuses on this part and all of this. So for this 55 to 60, there are 6 people. And then from 60 to 80, there are 16 people. So that gives us 22 over 124, which also simplifies to 11 over 62. That is your estimated probability for the person being more than 55 years. And with that, we're done with the questions for histograms. If you have any questions or confusions, please leave a comment below and I'll help you out. And if you understood everything, please like and subscribe, share this video with your friends. And don't forget to check out the other videos in this playlist because they're greatly going to help you in your exam prep.